A Tale of Two Gates. These short videos were included in the DVD Constructing the Stainless Steel Replacement Structure. They chronicle the process of exchanging the original main gate with a more substantial design and the assembly of the Roaring Gate in Fort Sta Cave. After repeated break-ins through the main gate at Fort Sta Cave, it was decided that the 3/4-inch solid bar gate be replaced with a new vandal-resistant gate design, constructed of 1 1/4 Schedule 80 pipe and 1/2 solid interior roller bars. The outer surface was hardened with hard surface welding rod to make the pipe resistant to cutting. The original 4-inch pipes sunk into the concrete foundation were still solid, so only the gate panels in between were replaced. Individual units weighing about 70 pounds were stacked on top of each other in the cave, welded to the large pipes and to each other. The project began on April 20th, 1996, when the measurements of the first sections were taken. The first panels were installed on May 25, 1996. This video documents the construction of the last panels, which were built from September 15th to September 20th, 1996, and installed in the cave October 12th, 1996. These are the measurements I made at Fort Sta Cave. The first thing I did was I measured the height of the posts. Then I used a plumb bob and a string to measure how level they were. And this one is odd level by 2 3/4 inches. This one was level. There was 9 inches of concrete on the foundation, which means I'm going to have to go around that. And then I measured the distance between the posts. And you can see the measurement is reflected in the difference between the top and the bottom. The next thing I did was I measured the height from the bottom of the foundation to the top of the roof on both sides. Then I picked a bar that went across right here, somewhere in the middle of the gate, and I measured from the top, from the bar to the top of the roof, and then from the bar to the ground. And I did that at 9, 18, 27, 36 inches. I used the gate, the pieces of the gate to measure across on each one of these for an easy reference. Then I used a line level to measure how level the bar that I used as a reference on the last measurements, see how straight that was. And as you can see, it was 4.5 inches off of being level. And that'll help me do my drawing on my table. This is a measurement of the last little side piece. That's the measurement of the post and the bottom along the foundation. And this is the measurement using the bar as a reference. Didn't feel it was all that necessary on that scale to see how straight it was. I do allow enough room around the iron that I do build
to allow for slight discrepancies, and that was much too short that anything is going to make that much of a difference. It was fairly level. I think it was maybe 3/4 of an inch out of level. Now I've got the contour of my ground. I drew my posts in, and then I drew the bar and the line level, and then I marked off how far I measured and then the height down to the ground, and then I connected the dots, and that gives me the contour of the ground. Now I'll start drawing the gate in. Now I've determined how I want to build the very bottom piece. As you can see, I've drawn in lines where all the pipes are going to go. And next what I'll do is I'm going to measure the angles where they meet. And I will then measure the individual pipes, and I'll cut them, and then we'll weld it all together. Now I've measured all the angles. Next, what I'm going to do is measure the length of each one of these pieces, and then I'll go ahead and I'll cut them all. This is called a cold saw. This is what I cut the steel with. And first thing I'm going to do is cut off the end here, and then I'm going to show how I cut the grooves in for the roller bars. Because the tabs are a little too long for the pipe, I use this hand shear to cut them down about 1/2 inch. The tabs only come with a 3/8 hole, so I have to drill the hole out to 9/16 of an inch. And that gives me just a little bit of clearance for the 1/2 inch rod. What I'm going to do now is wire brush the pipes. And the reason I'm going to do that is there's an epoxy coating on the pipe which makes putting hard surfacing rod on difficult. it also removes the rust. Another advantage of doing it now before the thing is put together is it's a lot easier to flip the pipes, and I don't have to flip the whole fixture. This is a plasma cutter. This is the machine I use to cope all of the risers or anything else that contacts the pipe. It needs to have a little curve in it, and that prevents from having large gaps to fill in with the weld. This is a jig I built to help me cut the curves in the risers, and I put the plasma torch into that and slide the piece of steel in there, and then I cut my arc. This is how I put the roller bar tab into the slot, made the two cuts, and now all I have to do is tap the tab in until it's flush. Then what I'm going to do is I'm going to put a spot weld here and a spot weld there, and I repeat that on both sides, and then we thread the bar in. This is what it looks like inside the pipe. Now, this is a good time to take a look at the wall on that pipe. That's a Schedule 80 pipe. It's got about a 1/4 inch wall on it. It's very, very heavy duty. And now you can see the tab on the inside. And then what I'll do is I'll thread my bar through there. And then that way that bar is free spinning. Now the tab has been welded into that slot, and of course then it's part of the pipe. Now I've got all the pieces tack welded over my drawing, and now I'm ready to weld it off. Now it's been welded off. It's ready to have the hard surface rod applied to it, and then it'll be removed from the table. This is the next section. I've got it drawn out, and then I'll cut all my pieces and weld it together.
Because of the size of the table, only 1/2 of each section can be built at a time. I've removed the bottom half and made my drawing of the top half. Keeping the weight no more than 75 pounds, all these individual pieces will be stacked upon each other in the cave and welded together.
This is the last section with the pipes drawn in. I'm ready to tack weld the pieces together.
Now here it's been welded off.
This is one of the sections set up to have the hard surface rod applied to it, and I have to leave it up like this to get the top and the bottom. What I do is I draw a line, and then I follow that line as I'm running the hard surface wire. This is the first pass. Now I'll flip it over and run another one on the opposite side. Okay, this is a completed piece. Altogether I ran 68 feet of weld on this. That's all 4 sides. The hard surface wire, what it does is it has a inner core with alloy material, and then there's the outer sheath of the steel. And what happens is when the arc melts the metal, it also melts the inner core and creates an alloy which is hard. This demonstration, you can see what that hard surface rod does. I cut the pipe, you can see the groove in it, but if you look at the hard surface rod, there's absolutely nothing wrong with it.
After hardening, a red oxide epoxy primer is applied using an electrostatic spray gun. The electrostatic spray gun charges the paint with 100,000 volts of static electricity, which makes the paint attractive to the metal with almost no overspray. A top coat of acrylic urethane protects the gate from the elements. Well, we're at Fort Sta Cave, and this is my installation truck. It's filled with the final main gate pieces, additional tools and supplies, some gas for the generator, and the cutting torch. It takes a little while to burn all this rust off. When the initial survey data of Snowy River was plotted in 2003, it was found that the side passage named Mud Turtle ended 45 feet under the breakdown in Don Sawyer Memorial Hall. The entrance at Priority 7 was determined to be too unstable to allow further access, so a new dig was proposed. But before it could begin, a gate at Roaring Hill would need to be installed. Constructed of the same hardened pipe and roller bar as the main gate, it was too deep into the cave to be welded in place. 3/4-inch square pegs were shock welded on the uprights, which bolted to the concrete foundation and the roof of the cave. The hardened pipes had square sockets shock welded into their interior, which slipped over the pegs, allowing the gate to be constructed entirely without welding and held together by the sleeve anchors in the uprights. The sleeve anchors were protected by small pipes welded around the holes in the mounting tabs and hardened plugs sledgehammered into the pipe to prevent tampering. The swinging portion of the gate was bolted together with flathead bolts, Loctite applied and impact wrenched together. The first half of the gate was fabricated by Jim Cox with the help from Cal Currier, Ed Payton, and Rick Reynolds, starting in April 2004 and installed October 9th and 10th, 2004. The second half was fabricated over the winter months and installed April 30th and May 1st, 2005. The Roaring Gate project began April 11th, 2004, when Jim Cox, Cal and Grace Currier, Ed Payton, and Rick Reynolds packaged 2,500 pounds of concrete into 10-pound bags for a total of 250 bags. April 18th, 2004, Jim Cox and Ed Payton dug a trench for the foundation. After a few inches down, the clay started to stick to the shovels, so it ended up taking one man to dig and one man to scrape the clay off the shovel. Concrete, along with rebar and water, was hauled by members of the Hondo Grotto, Fort Sta Cave Study Project, and a troop of Boy Scouts from Roswell on May 1st, 2nd, 3rd, and on the next weekend, the 8th and the 9th. May 29th, 2004, John and Dorothy Corcoran, Jim Cox, Ed Payton, Cal Currier, Mike Bilbo, and Rick Reynolds carried water to the gate site. Jim and Ed mixed concrete. Mike and Rick cut the bags open and dumped concrete and water into the mixing tray. Cal moved empty bags and bottles to a temporary dump site and moved full bags and bottles to the gate site, allowing mixing to proceed without interruption. John and Dorothy performed photo documentation. With the foundation poured, the first set of measurements were made on May 1st, 2004. Other trips to refine the initial measurements were made July 3rd and August 7th, 2004. This time, a laser level was used instead of a line level and plumb bob. Over the summer months, the first half of the gate was fabricated and installed on October 9th, 2004. Well, this is the half of the gate we put up here in October of 2004. This is half of the Roaring Hills gate. We'll be putting the other half in April, just as the cave opens up. And here's the gate crew. They packing up, getting ready to head back up to the surface. There's Ed. There's Frank. And there's Grace and Cal. The second half was fabricated over the winter and installed on April 30th, 2005.
Okay. Now I'll take a pen and I'm going to write my Fort Sta number on there. Reached into.
Crawlway that you had to go through, and we could only bring one bar in at a time.
Oh shit!
And what do
there
you
was
have
no
to-
way to bring a structure in.
Right.
And
Jim was doing the tight, or Rick was doing the tight.
yeah. After you get up there, you got to finish pounding it up in there.
Yeah. I knew that. I was just testing.
You're
Hal, did you bring us some beer?
No.
Oh man!
Should have said
Actually,
something.
he's lying. We were bringing it in, but we drank it on the way in.
We know, Cal. Give you some more or less angle.
So how's this feel? Good and solid?
Hell yeah. Like the gate. No spillage.
Okay, next post.
Let's
I can take a half-inch of concrete easy.
Okay, stick it back on there. Then let's tap it and make sure it's on there all the
put
way.
an inch of mud on that, baby. It's up there all the way.
Okay,
It
now
slides
go.
on it.
Yes.
It slides on real nice.
And I need to put some down. No, I think it's-
Ooh, that was right. What's that?
Let that rock cool a little bit and you have all kinds of fun getting it loose.
You know what you do? Pop the cap on there. It's as good as an anchor.
Right. Thread it and screw it.
Here, boy, this here. Alright. Which finger?
Well, with the hammer.
Screwdriver. Turn the bolt around. Use the head. Use the head.
Oh no, it's alright. It's in there far enough. There you go, ratchet.
Ratchet
Oh,
man.
the ratchet man's gonna get it.
The ratchet man.
You can't take his job, huh? Union here, huh?
That's his one job, run the ratchet. The union hand. Got the card in his pocket.
It's the best
The
job.
Union
ever.
Ratchet Man.
It's work your way up and you'll go work your way to ratchet man. That's
Yes.
the drill. After drilling.
Lay that dust on there. That would be a better picture.
Uh-huh. Alrighty. I think JB Weld would be a better filler for that than concrete.
You just have to clean it up more. Concrete will absorb that shit. JB welding. Make a layer and keep it separated from the rock.
Really?
Yeah.
JB Weld sticks to everything.
Except
wet rock.
Except wet rock and a layer of dust.
Uh,
It'll stick to the dust. It'll
We
get
got
to
the
the
blower,
rock.
we can blow the dust off.
Actually, we figured about 2 years on the original gate here.
uh-oh,
They had it with JB Weld.
we're stuck now.
Oh, no.
And we care why. We're on the right side.
Where'd you say those stakes were in?
In the freezer. There you go, Jim. Rick, let me get this.
We're cleaning the gate up. There's a lot of mud on it from dragging it down here and then working on it. I'm using Rick's big old spotlight.
Probably